Venn diagrams continued. This one is something that you probably won't necessarily see. I wanted to push the envelope here and actually create and talk about kind of Venn diagrams with regards to four subsets or kind of four circles and how to create them. To be honest with you, on two-dimensional plane, the Venn diagram doesn't really work, but we still should have some kind of a sense on how to approach these questions and then answer what might be asked of us. So, in this example, you're dealing with infections, and then there's four different regions that we're going to be dealing with. So I wanted to first, in general, just show you how to approach and how to find the total union. So the total number, okay, of, for instance, items or elements, in this case infections, that there have been in the union between all four regions. So you know kind of what to do when there's two circles, right? Two regions, or basically two subsets, and then how to count the total. When doing three subsets, you have the three circles in Venn diagrams, and again, it's actually pretty doable. You can visually see it. But when you're dealing with four, unfortunately, it gets a little bit harder to be able to do that. So what I want to show you here is, given four subsets, how do we find the union, the total number of elements in the union? Okay, so what that means, I'm going to kind of skip this example for the moment, and I'll come back to it just to show you the application. So really what we have is, okay, if there's four, I'm going to call them A, B, C, and D. So these are my A, B, C, and D. Okay, so these are my subsets. So what could possibly happen? Well, someone can give you, the total number of items in the first subset. Someone can give you the total number of items in a second subset, okay, B, and so on. So that's going to be the first thing. So we can get and identify all of these particular numbers. All right. Now, what's next, okay, is, so if I'm going to draw a line here for myself to separate, now there's an intersection in between them, right? So you can have something like, okay, what's the total number when A is intersected with B? Because that certainly matters. Okay, because if you're going to be counting the number of items in A, well, you're going to be repeating it once again if you have the intersection between A and B, because clearly the A is already in that intersection, all the items. Okay, so now what else? Well, you're going to run into A kind of intersected, okay, with C, and you're going to run for all the numbers between A intersected with D. Okay, and then, so I'm going to kind of finish this off. So we're going to have B intersected with C, and then also you're going to have B intersected with D, and then finally, the last one is C intersected with D. All right, so we have all of those, right, that we have to worry about. But that's not it, okay, because now, so that's the intersection between two of them. But what about now the intersection between three of them? Okay, well then that gets annoying, because now it's going to be A intersected with B and intersected with C. What if we count those up? Then it's going to be N, okay, so the number of A intersected with, I guess it's going to be C, right, or sorry, B and D. Okay, let's start with that one. A, B, and intersected with D. All right, now we're going to have N, okay, intersected with, and now it's going to be A intersected with C and D. So that's the three of them. I'm going to run out of space here. I'm going to put a page extra one. All right. So, what else in terms of the three intersections could there be? Well, there's going to be N, I guess, intersected with, right? So this is going to be B intersected with C, intersected with D. So those are going to be the ones that we're going to be dealing with. Okay. Now, those are all the three intersections, because there's no other ones that we would have. So finally, this leaves us the last one, and that's going to be the intersection between all of them, A, B, C, and D. Okay, so that's a lot. Okay, I mean, if you look at this, that's going to be quite a lot of information within here. And now from these, okay, so from all of these, if we wanted to be able to add them up, okay, and this is something that you're going to have to try to do for yourself to be able to see this. I'm going to try to guide you along. If you wanted to be able to find, again, if you want to find the union, so N, the union between A, B, C, and D, then to do this, you clearly are going to have to add. Okay, so you're going to have to say, okay, I'm going to be adding this, right, within here. I'm going to be adding this, this, and this. Now, if I add all of these, then clearly I've counted twice, okay, the other ones, okay, or sometimes even more, okay, as I keep going along. So if I do this, definitely the other ones got counted again. So how do I approach this? So I'm going to kind of do this one by one. If we count A, right, so now we can see, okay, where else have we counted A then? Well, it would have been counted here, 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 okay? It would have been counted here, here, I guess right here. Okay, so that's there. And then it would have been counted here as well. Okay, so that's all my A's that would have been able to be able to count. Now, if I do the same thing with the B, okay, so if I count B now, like this, then that means I've also counted it here. So now notice that one now gets double counted already. Okay, and then I'm going to, so where else is B? So B is right here, and B is right here. And then B is right here, B is right here, and B is right here. So I see that. And then B is right here as well. All right. So that's what we have within there. Now, if I count C, then I see C right here. I'll see C right here, C right here. So I see those. And then we're going to see C here, and C here, and C here. And then, of course, right here. So notice, by adding the number in A plus the number in B plus the number in C, I've now also double counted or sometimes triple counted some of the other ones that I have. And that is obviously a problem that we have to be able to remedy in some way. So now for the D, okay, so D is right here, D is right here, and D is right here. And now, so within here, we see D here, D here, and D here. Okay, so we have that, and then D was also within here. So that's interesting. Okay, so that's just counting up the first ones. So now we've done these, right? So what should we do with the rest? Well, clearly the union cannot be just, NA plus the number in B plus the number in C plus the number in D, because we have double counted and sometimes triple counted the other ones. So clearly, so within here, notice, now I'm going to go through here, through these. These were double counted. So I'm going to subtract one of them because, so I'm going to take away or subtract NA intersecting B because I have two of them, right? I've counted them twice already within here. So I certainly don't want to be able to do that. So I'm going to be subtracting these. Okay, so let's do that. So let's subtract. So subtract, I'm going to put a cross here. So I'm going to subtract that. But now, where else do I see A and B? Well, I see it here. So that means this is going to get subtracted. A and B, this is going to get subtracted. And then this is going to get subtracted. Okay, so now let's subtract the other ones. Now, what about this one? So if I subtract this, A and C, then, so A and C, so this is going to get subtracted. This is going to get subtracted, right? That's A and C, and then this is going to get subtracted. And I can continue this. I'm going to kind of interlace these back. So I'm going to subtract this, A and D. So that's going to subtract this for me, A and D here, and A and D here. And then this. All right. Now let's subtract B and C. So that's going to subtract this for me, B and C here. Then B and C right here, like that. All right, let's continue. Now let's subtract B and D. That's B and D, B and D, B and D. So that's going to subtract those. And then let's do the last one. So that's this one, which is C and D. So that's going to subtract this one. So let's subtract this one and this one. So notice, so now that means, okay, so we've counted the only A's once. So you see only one check mark there. Now, because we've subtracted these right here, so that got rid of, you know, each check mark in here. So that subtracted one. So that means I've only now counted them one time, which is what we wanted. So within here, so what I would have is, okay, so this is going to be now minus. So this plus this plus this plus this minus. Now all of those, so that's going to be, okay, N A intersected with B minus N A intersected with C minus N A intersected with D. Okay, so subtracted. N B intersected with C minus N B intersected with D. So I'm doing all of those. Okay, subtraction of those. All right, but now because of this subtraction, notice that I've now over subtracted. So now notice that I've counted these 3 times when I was doing this. But now, because I've subtracted, now I've also subtracted these. So I have 3 additions, 3 subtractions. So now I have not counted the intersection of A intersected with B intersected with C. So meaning 3 of those subsets were not counted because they just cancel off. And notice that happens for all of them. So that means that within here, so my next, you know, step is, okay, so that means I have to count these now. So if I count this, all right, that's A, B, C. Now I'm going to count this again because I see A, B, C here as well. Okay, and now if I count this, A, B, D, I also count this. If I count this, again, I count that. If I count this, so now this gets counted. But now notice that within this, each of these rows, so within these rows, if you count up the check marks and the subtractions, the crosses, you only have 1 again. So that now only gets counted once. But let's see what happens at the end. So all of this is true for all of these. But now in here, let's see what happens. Okay, I'm going to go with red here. So I had 1, 2, 3, 4. I counted them 4 times. Then I subtracted them 1, 2, 3, 4, 5, 6 times. Okay, so now I'm minus 2. So I've subtracted them. I've excluded them 2 times. I've added them 1, 2, 3, 4. So now again, I am plus 2 because now I counted them up again. So that means I have to finally at the end now subtract one of them to finally get the total union. Now that is crazy. If you're able to follow that, okay, and see, you know, how do you count these up, then this becomes something that you can kind of conquer. So within here, so I would have to say, okay, so now I'm going to be adding. So I'm going to add these. A intersected with B, C, plus the intersection A intersected with B intersected with D, okay, plus NA intersected with C intersected with D, and this is B intersected with C intersected with D. And then finally my last one, now I have to subtract the last because I've done it too many times. So notice the pattern. Add, subtract, which is interesting because if you would do and see the example where there were 3, okay, then you would be adding, subtracting, adding, right? If you were only doing 2, it was add, subtract. So there's a pattern, okay, in between. And if anyone ever asks you, okay, what if you had n subsets, then what would you do? How would you count the total union of items? You would just simply take the addition first, okay, then the subtraction when they are 2 subsets of intersection, then again, okay, addition, and then subtraction until basically you're done. So that's how you would approach this. So with this example, because this is going to be a very long example that we have in here, we're going to be able to actually do all of these items. Okay, so we have a total of 1,256 infections have been recorded in a span of 2 days. And now there are 4 regions here. And now it gives us all the information for these. So I'm going to remove these and I'm going to just write the numbers for all of them, and then we will use this formula to find out exactly what the total number would be. Okay, so now let me just I'm going to remove this whole thing right there so that I can clear this up. So delete. And so what we're going to do is, I'm going to just fill out how many total numbers did I have. All right, so we have, this is for these. And so that I'm going to get directly from the information. So I'm going to do this in fast forward fashion. I'm going to just fill out the numbers, but just so that you can see. So here, notice it says in region A, right here, there was 109. Region B, 87. Okay, region C, right here, 89. Okay, and then region D was 63. So all I'm doing is I'm just trying to write these numbers out. So 109, 87, 89, 63. Okay, and I'm going to fill out now the rest. Okay, I'll do that in fast forward fashion. We'll see you right back. All right, so welcome back. Okay, so I put in all the numbers in. So what we're going to do now is we're going to just simply say, okay, we'll add all of these. So that's going to be the addition of those. So that comes from this formula. So you first add all of them. So 109 plus 87 plus 89 plus 63. Okay, so that's 348. Now, these we have to subtract because they were double counted now. That's what this shows us. So the intersection between them, we're going to have to subtract. Okay, fine. So minus, so 38 minus 28 minus 26 minus 17 minus 21 minus 11. All right. So far, so 207. So 207 after adding these and subtracting these. Now again, so now we add these up. So here's my answer. Now we're going to be adding them. That's right here, the addition. Plus 19 plus 15 plus 9 plus 8. All right. Now we've added that. That was 258. And then this last one we have to subtract. Minus 4. So this whole entire thing, so 254 infections in those 4 regions as a union. Okay? And that's what they asked us here. How many people were infected in the 4 regions? Now, to B, how many people were infected in other regions? Well, if there are 1,256 in total, and 254, so minus 254, so that would have been 1,000, I guess 2. Okay, so that's how many infections in other regions. And now the last question, can you create a Venn diagram with this? So creating a Venn diagram with these is really tricky. And I say that, let's put in here another page. And let's make this bigger. Because if you wanted to create a Venn diagram, you need 4 circles, right? So let's say you had 1. Okay, I'm going to try to duplicate this. So here's, let's say here's another one. Duplicate it again. How would you do this? You would have to do something like this. Duplicate it again, and then you would have to do something like that. And, so let's say if we call this A, B, C, and D. So this seems to work, right? So here's the intersection between A and B. Here's the intersection between maybe A and C. Okay, but now notice, where's the intersection between only A and D? Nowhere, right? So Venn diagrams here are really hard. You would have to almost do a 3D here, in some form or way or something like that. So it's very difficult, right, to be able to actually have all of these different cases, right? So is it possible? No, it's actually not possible to be able to do that throughout, because now you're missing. Notice that A and D, only A and only D, that intersection. I mean, unless it's empty, right, then this would work, but you also would need an empty between B and C, right, as well, okay, so that you don't run into these problems. So creating Venn diagrams here is tough. That's why knowing this formula and understanding where it comes from is pretty useful. But for most part, when you're studying this, let's say in a data management course or something of that nature, or Venn diagrams, most teachers will not push you to the 4 region or 4 subset area. They typically will stick a maximum of 3 where you can nicely visualize that for yourself. All right, so this was a super long example. If you understood it, amazing. I would encourage you to try it, dwell on it. You can post comments too if you have questions, if you didn't understand something, let me know. Okay, thanks for watching. See you in a future video. Okay, and happy studying. Bye, everybody.